Here we are at our final presentations of the different neurotransmitters that you presented. And so now we'll continue now with Milena's presentation on histamine. Histamine you've heard of, especially because you've heard of antihistamines. But histamine is classified in this kind of a different category of an amine. And an amine is basically something that has a particular structure to it. Particularly you see this NH2 on this side, and you also see an NH and a bunch of nitrogens in here. So it's sort of based on the structure of ammonia. And how it forms is it forms from an amino acid, and that amino acid is called histidine. So histidine will get decarboxylated, and just for you chemistry nerds out there, that basically means we're going to remove a carboxyl group. So here, right here, I'm circling with my cursor the carboxyl group that's here, and through the use of this enzyme, the body will take histidine and it will remove this carboxyl group with histidine decarboxylase, which is the name of the enzyme, and produces histamine. Now, this histamine is going to be found in a lot of places, and there's brain histamine, and then there's histamine we'll see in the body. So when we look at histamine, we're looking at it at first as it is a neuromodulator. So we're going to look at it a little bit in the brain and what it does. So it's a modulator, meaning it's somehow going to be involved with modifying the release of other neurotransmitters, such as acetylcholine, norepinephrine, or serotonin. It has 4 different postsynaptic receptors. So on the postsynaptic side, we'll see one of these 4 types typically. But it also has presynaptic receptors, which means it has something that can control the amount of histamine actually released. We're going to see this coming up again a little bit later. So in the central nervous system, these histaminergic neurons are in the posterior hypothalamus, and they extend their axons, though they aren't going through the pituitary gland like the others that we just looked at. They will be producing histamine and sending their projections widely throughout the central nervous system. And I'll show you a picture in a minute. So in the brain, histamine is associated with a lot of things, but its main association is probably with sleep. So histamine cells are basically very active during the day when we're awake, and much less active when we're resting. And in particular, they don't even act at all. They don't fire any action potentials when we're having REM sleep, which is that rapid eye movement sleep that we associate as our dream state mostly. If there are really low levels of histamine, that's had some correlation with people who have schizophrenia. So let's take a look at the area of the brain that is involved with histamine production, and we're kind of looking at it right in here, and you can see what we mean by broad. It projects all over the place. You can see it throughout the cortical areas, up here in the frontal cortex, helping with the state of alertness, but also activating all sorts of other neurons and pathways along the way. All right, in the peripheral nervous system, this is where we're most familiar with histamine. It's produced as secreted by cells in the immune system called mast cells, and it plays a role, as we know, in lots of allergic responses. So it's a signaling molecule, and it signals lots of stuff. One of them is it instructs stomach cells to make stomach acid. We already mentioned about the brain piece of it. And antihistamines are specifically to oppose, or we take them to oppose the effects that histamine might have within our body that will cause other issues, like when we have a severe allergic reaction, we get a lot of swelling, we get a lot of inflammation in an area, antihistamines can reduce that, and they can reduce the production of stomach acid, so they can be used to treat acid. The antihistamines can be used to treat acid reflux. If we take them, they can make us really drowsy because they also have an effect on our brain levels of histamine. So antihistamines mean against histamine. So histamine is we already mentioned this role in the immune system, and this is information you don't need unless you want to kind of learn a little bit more about how it's made and who releases it, and how this actually has some kind of an effect on when something is an allergen or something is in our body that's an invader. So this talks a little bit about the IgE cells, the immunoglobulin E cells, which produce chemicals that warn our immune system about a foreign invader, and then the mast cells and basophils, which are also part of our immune response, will pick that up, and then they release histamine to help as a part of this all-out response to this invader. And last, but certainly not least, and actually was our first presentation was by Bridget. And Bridget did a great presentation on adenosine. And adenosine is an endogenous ligand, meaning that it's produced within the body, and it acts as a ligand on the receptors of certain cells, especially in the brain. We see adenosine levels are going to increase throughout the day as adenosine triphosphate, ATP, is used during normal cellular activity, because remember, this is an energy molecule. It too acts as a neuromodulator, and it's going to alter some of the activity that would normally occur at a synapse. And so as adenosine builds up during the day and starts to activate these different receptors, particularly in the forebrain area, it starts to inhibit those areas, and it starts to make you feel sleepy, basically. Caffeine goes in and blocks those adenosine receptors, and therefore acts as an antagonist. So caffeine would be an exogenous, exogenous, right? Because we ingest that. That's not what the body makes. We take it, and it goes in and it acts as an exogenous antagonist, meaning it comes in and blocks these receptors and will reduce those sleep-promoting effects of adenosine building up. And so just to show you this as a picture, this is what happens here, 7 a.m. Right now, we're assuming this is when someone wakes up. We're going to have very low levels of adenosine, but as the day progresses, as you keep thinking and using your brain and using energy, it gets later and later, those adenosine levels build up, and they are a secondary way in which sleep is induced. So they aren't the only way, but they're certainly sleep-promoting areas or effects. And here you can see this basal forebrain nuclei in here. Well, that's kind of what I wanted to focus on here. So it's a lot of this area that adenosine has some pretty strong effects on. And last is the one that I'm presenting, and I've talked a little bit about it, but not too much. This gas, which is called nitric oxide. It is interesting because nitric oxide is actually also a poison, just like carbon monoxide is a poison. But interestingly enough, in the nervous system, it serves as some type of a neurotransmitter or a neuromodulator. And I'm going to talk about this a little bit. And I'll bring up this term retrograde because it's a very unusual scenario. It wasn't even understood to be a neurotransmitter at all. For years, there was even argument over that. And so we'll look at this in a little bit more detail coming up. The last slide I wanted to show you is not because I want to go back necessarily to these neurotransmitters, norepinephrine, serotonin, and dopamine. But to show you that a lot of these have interactions with one another, so that if you're looking specifically at mood and cognitive function, we can talk about all three of them, because all three of them play some role in that. If we're looking at anxiety, or impulsivity, or irritability, we might be talking more about the norepinephrine or the serotonin systems. If we're looking at reward pathways in particular, we're going to be looking more at dopamine. But there's overlap, and that's because it isn't a single neurotransmitter working in a single pathway. It's many neurotransmitters, some of which are altering the functions of some of the others, including the glutamatergic pathway or the GABAergic pathway. So we'll talk more about this, but I thought it'd be a good place to stop. So that's it. Yay, we did it.